So this is the third lab of episode 1 class. Today our topic is plate tectonics. So in the lecture, I guess you guys have learned about the crust. And if you remember the Google Earth presentation, when you try to find your landform on Google Earth, you will find some like continents, some oceans. So these continents, their crust type is continent crust. For the ocean, we have two types. You see, there is one region with light blue color. This is actually the continental shelf, and it still belongs to the continental crust. And the darker blue one, they are deep ocean, and they belong to the oceanic plate. Oceanic crust. So on the right figure, you see a brief illustration for the continental crust and the oceanic crust. Usually the continental crust is thicker than the oceanic crust. So usually it's above the sea level. Even though it's below the sea level, the ocean depth is much shallower than the oceanic crust. Some other physical properties comparison. So the continental is thicker and older and less dense. The oceanic is thinner, younger, and more dense. And for the plate and the plate boundary, we know the ridged layer at outermost of the Earth, we call it lithosphere, and also call it plate. But this lithosphere is not an intact layer. It's actually divided into several parts by the boundaries among different plates. So for the types of boundary, in general, we have three kinds of boundary: the divergent one, the convergent one, and the transform one. At divergent one, we see two plates on two sides moving away from each other. You will see at the boundary, the crust is actually expanding. For the convergent one, two just move towards each other. And the lighter one will go down, and the denser one will on the top. So finally, the lighter one go down to the mantle, and the crust will be destroyed in the mantle. The final one is the transform boundary. This is the boundary where two plates move parallel with each other. So at this boundary, actually, no new crust is formed and no old crust is destroyed. Let's first take a look at one example of divergent boundaries. This is a figure showing the mid-ocean ridge, which is the divergent boundary appear at the mid of the ocean. So at atmosphere, which is beneath the lithosphere, we have some mantle materials going up. When it reaches the surface of the Earth, it will cool down very quickly and form the new rocks at the mid-ocean ridge. And this kind of new crust will push the lithosphere on two sides away from each other. So it's a divergent boundary. The right figure is not very clear, so we can first skip the figure. You will have a chance to look at them carefully in your lab assignment questions. The second one is convergent boundary. We know the convergent boundary is two plates meet each other. Depending on the types of two plates, we have three subgroups. The first one is oceanic plates meet the oceanic plates. The second one is continental plates meet the continental plates. And the third one is oceanic plates meet the continental plates. For this kind of plate boundary, we have an academic name for it. Usually we call it subduction zone. If it's two continental plates, because they collide with each other, so we call it collision zone. The third one is transform boundary. If you remember what I have said before, two plates, they move parallel with each other. And the right figure is a very good example for the transform boundary. Before two plates move, we expect these red rocks align with these red rocks, and these blue and green rocks align with these blue and green ones. But after the transform boundary formation, two plates began to move. So we see an offset in between. So the black line shows the traces of the transform boundary, and the arrows indicate the moving direction of two plates. Here are some terminologies you will meet in plate boundary systems. We have change, we have four-arc basin, accretionary wedge, volcanic arc, rift valley, hot spot, and passive marines. So in next few slides, I will go through them briefly. This is the figure showing the how this change, this four-arc, volcanic arc, and the accretionary wedge looks like. So we began from the ocean. This is the oceanic crust, and it goes down to the mantle beneath the continental crust. This is the sea floor, and if you go to the land side, you see where the oceanic plates meet the continental plates. The deepest part beneath water is the change. In the meantime, we have some sediment layers on the top of the oceanic crust. They are very light. Their density is smaller than continental crust, so they do not go down into the mantle. On the other hand, they will gradually accumulate near the change, and finally it formed, we call it accretionary wedge. And then if we go to further land parts, we will see some volcano trims here. So the formation of this volcano is because the subduction plates bring the water into the mantle, and at the mantle, the temperature of the water rise up and will change the physical properties of the mantle materials above that. So after mixing these hot waters with the mantle materials, you will have these materials melted and it goes up to the Earth's surface. And finally, after it reaches Earth's surface, it's erupt and become the volcanoes. And finally, it's the relative plain basin further on the land part. We call it foreland basin. Rift Valley. This is a divergent boundary. So if the divergent boundary appear in the ocean, in the middle of ocean, is mid-ocean ridge. Yeah. If it appears on the land, on the continent, is Rift Valley. We have the new continent crust formed in the mid, and pushing two sides, moving away from each other. And this newly formed crust is always thin, and their altitude is very low. So this is why we call it valley. And one very famous Rift Valley is the East Africa Rift Valley. the hotspot is a very special thing. Actually, it does not appear on the plate boundary. It can occur at mid of the ocean plates. For the hotspots, scientists still don't fully understand the formation of hotspots. They proposed some hypotheses to explain why these hotspots appear. One famous hypothesis is at mantle, we have a very hot point, and this hot point is fixed. This hot point will cause the volcano on the top of the crust. In the meantime, the crust is moving rightward in this figure, moving rightward, but hot spot is fixed. So this volcano moving rightward and becomes this one. The new volcano will be formed at the hotspot point. If this one also moves rightward, and then it will become this one, and we have another new volcano form. Finally, we will see many volcanoes and form this kind of volcano trains in the middle of the ocean. You can see these two white arrows. They show the moving direction of Pacific plate. It's moving to the west and moving to the north. So you will see this. Here we have a Hawaii ridge. This is volcano chain, and another volcano chain here. Okay, finally is the passive marines. This is the marine between the continents and the ocean. We call it passive because this is actually not a plate boundary. The tectonic here is not active. The formation can be explained by the right figures. So a long time ago, this is an intact continent. But one day, the mantle began to going up and began to push two sides of the continent to move away from each other. And finally, we have this newly formed crust. This is very thin, and its elevation is very low. Its altitude is very low. So if it's below the seawater level, the water will fill this part, and then this becomes the marine of the ocean and the continent. So pay attention to this part. This is what we call continental shelves. Although it's buried beneath the water, it still belongs to the continental crust. And at here, if you go further to the ocean side, at some places you will see a very sharp drop in the altitude of the ocean bottom, and then it becomes the oceanic crust. This is a cross-section view, a side view for all these plate boundaries. You see here is a convergent boundary among the oceanic and the oceanic plates. This is the hotspot and the mid-ocean ridge, the divergent boundary in the middle of the ocean, the subduction zone where continental crust meet the oceanic crust, and the rift valley where the divergent boundary occur in the middle of the continent. This figure can be a good reference for your homework 1. You need to draw a similar cross-section, but can be simpler. And finally, we still need to use Google Earth for today's lab assignment. We need to import the plate tectonic boundaries to the Google Earth to help us answer some questions. So I will show you how to import the boundary files to Google Earth. So if you go to modulus, currently we are week 3. So we have plate boundary files here. KMC is a KMC file. We can download to your computer, but we don't need to open that. I think your computer don't have software to open this file. What we need to do is to import these boundary files to the Google Earth so that we can see them on the top of the Earth. So so this is what I imported for the last class. I will first delete this one and show you how to do that. Here, I first delete the old one. So if you open Google Earth, this is what you will see. So to import the boundary file, we click New. Okay, New, and we already downloaded the file, so we import from local. And this one, plate boundaries.kmc. Yeah, after you do that, you will see you have some color lines on the top of your Google Earth. These color lines, they are the plate boundaries. And on the top left, you have legend for them. So the green lines, they are divergent boundary. Red lines are transform boundary. And the blue lines are convergent boundary. We also have these arrows. For example, San Diego here. The black arrow showing the motion of the plate. If you click the arrow, you will see some details. See the moving rate, moving speed of the plate. For example, here near San Diego is 50 millimeter per year. And if you click the boundary itself, for example, the red line here, on the top right, it will give you the name of plate on two sides. So near Los Angeles, this boundary have North American plate on east side and the Pacific plate on west side. Yeah, so I think that's all you need for your lab assignment. For the rest of time, you can go to the assignment 3, week 3. If you have any question, just raise your hand and I will come to your assist to help you.